Okay, good day class. I am your teacher right now. So our topic for today is all about factoring polynomials. And this is our learning objectives. May I request Miss Jolene Katapan? Please read.
Objectives. Through varied learning activities, the grade 8 students with at least 80% of accuracy shall able to first, define factors, factoring, and GCF or greatest common factor. Second, solve factoring polynomials with GCF. Third, demonstrate factoring trinomials in the form of x squared plus bx plus c using FOIL method.
Okay, but before we proceed to our topic, which is factoring polynomials, let us define first the word factors in mathematics. So what is factors in mathematics? May I call on Mr. Gcf? Please read.
Factors, either numbers or polynomials. When an integer is written as a product of integers, each of the integers in the product is a factor of the original number. When a polynomial is written as a product of polynomials, each of the polynomials in the product is a factor of the original polynomials.
Okay, thank you so much, Mr. Gcf. How about factoring? What is factoring? Mr. Albarico, please read the definition of factoring.
So, factoring, writing a polynomial as a product of polynomials.
Thank you so much, Mr. Albarico. And now let's proceed to GCF, or the greatest common factor. May I request Miss Kausing, can you please read?
So when we say GCF for the greatest common factor, it is the largest quantity that is a factor of all integers or polynomials involved.
Okay, thank you so much, class. We already defined what is factor, what is factoring, and what is greatest common factor. And here we are now. We have an examples of the greatest common factor and how to find the greatest common factor of each list of terms and numbers. We have 4 examples. The 2 examples are referring to numbers, and the other 2 examples are referring to polynomials. Okay, let's try to answer the greatest common factor or the given examples, and we need to find the greatest common factor. First, the first step that you need to do is get the factor of each terms. First, we have 12. So the factor of 12 is 2 times 2 times 3. That when you get the product, it will also gives you the original number, which is 12. Next, 8 is equals to 2 times 2 times 2. Get the common terms, this. Therefore, the greatest common factor of 12 and 8 is 4. Next, second example, 7, 1 and 7, 20. The factor of 20, we have 2 times 2 times 5. As what you can see, there are no common terms on both 7 and 20. Therefore, the greatest common factor of 7 and 20 is 1. Next, let's proceed. Example number 3. We are referring to a polynomial. So the x cubed is equals to x times x times x. X raised to 7 is equals to x times x times x times x times x times x times x. Get the common terms. We have this, this, and this. Therefore, the greatest common factor of x cubed and x raised to 7 is equals to x times x times x, or x cubed. Next, example number 4, we have 6x raised to 5th. Factor first. Get the factor of 6x raised to 5th. We have 2 times 3 times x times x times x times x times x. And 4x cubed is equals to 2 times 2 times x times x times x. Okay? Therefore, the GCF the GCF of 6x raised to 5th and 4x cubed is 2 times x times x times x, or 2x cubed. Okay? Now you have an idea on how to find the greatest common factor of the terms. And now let's proceed to our main topic, which is factoring polynomials. The first step in factoring a polynomial is to find the GCF of all terms. Then, we write the polynomial as a product by factoring out the GCF from all the terms, and the remaining factors in each term will form a polynomial. Example, first example, we have 6x cubed minus 9x squared plus 12x. Let's try to get the polynomial. 6x cubed minus 9x squared plus 12. According to the definition on factoring polynomials, we need to factor the first term. The factor of 6x cubed, we have 2 times 3 times x times x times x. Then, negative 9x squared is equals to negative 3 times 3 times x, and the 12 12x. Okay, 12x, we have 2 times 2 times 3 times x. We need to find the common terms. We have 3, 3, and 3. Then we have x, x, and x. Okay, get the product. We have 3x. Then, okay, 2 times x, we have 2x squared, negative 3 times x minus 3x, and 2 times 2 is plus 4. And now these are the factors of 6x cubed minus 9x squared plus 12x. Next, example number 2, 4x cubed y plus 7x squared y minus 7xy. factor the first term, for x cubed y is equals to 2 times 2 times x times x times 14 rather. 14. Okay. So the factor of 14 is 7 times 2 times x times x times x times y. And the second term is 7x squared y is equals to 7 times 1 times x times x times y. And the last term is negative 7x y is equals to 7 times negative 1 times x times y. So the common factor, we have 7. What else? X, 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 and y. Okay, get the product. So we have 7 times x times y, which is equals to 7xy. And 2 times x, we have 2x squared. 1 times x times x, plus x, negative 1 minus 1. And that's the final answer. That's a factor of 14x cubed y plus 7x squared y minus 7xy, which is 7xy times 2x squared plus x minus 1. And remember, factoring out the GCF from the terms of a polynomial should always be the first step in factoring a polynomial. Example, factor 90 plus 15y squared minus 18x minus 3xy. Okay, 90 plus 15 squared, 15y squared minus 18x minus 3xy squared. The factor of 90 is equals to 3 times 2 times 5 times 3. Then the 15y squared is equals to 3 times 5 times y times y. And negative 18x is equals to 3 times 2 times negative 3 times x, and negative 3x y squared is equals to 3 times negative 1 times x times y times y. So that you can see, we need to find the common terms or the greatest common factor. We have 3. What else? 2. Okay. Wala. How about 5? Wala. How about 3? Okay, therefore, the greatest common factor, the GCF, is equals to 3. And we need to factor the given. So 3 times, get the product, 2 times 5, 10 times 3 is equals to 30. Okay, 30. Next, get the product, 5 times y plus 5y squared. And next, get the product, 2 times negative 3 is negative 6 times x. We have negative 6x. And get the product, negative 1 times x is negative x times y is negative xy squared. And now this is now the factor or the final answer of 90 plus 15y squared minus 18x minus 3xy squared. Now let's proceed to factoring trinomials. Factoring trinomials in a form of x squared plus bx plus c. Recall by using the FOIL method that x plus 2 or quantity x plus 2 times close and open parenthesis x plus 4 is equals to x squared plus 4x plus 2x plus 8 is equals to x squared plus 6x plus 8. To factor x squared plus bx plus c into quantity x plus the first number times x plus another number, note that b is the sum of the two numbers and c is the product of the two numbers. So, we'll be looking for two numbers whose product is c and whose sum is b. Note that there are fewer choices for the product, so that's why we start there first. Example, factor the polynomial x squared plus 13x plus 30. Since our two numbers must have a product of 30 and sum of 13, the numbers or the two numbers must both positive. Positive factors of 30 is 1 and 30, 2 and 15, 3 and 10. Sum of factors of 30 is, by getting the sum of 1 and 30 is 31, 2 and 15 is 17, 3 and 10 is 13. Note, there are other factors, but once we find a pair that works, we do not have to continue searching. So, x squared plus 13x plus 30 is equals to x squared plus 10x plus 3x plus 30, or x times x plus 10 plus 3 times x plus 10 is equals to x plus 3 times x plus a FOIL method. Example number 1, we have x squared plus 9x plus 20. Before that, we need to get the factors of 20. We have 1 and 20, 4 and 5, 2 and 10, and sum of factors. Of this, we have 21, and this, we have 9, and this, we have 12. As what you can see, we use positive numbers because all the numbers or in every term that we used are both positives, are all positives. Therefore, we need to use the positive factors of 20. And as what you can see in the middle part, or the value of b, we have the 9 or 9x. Therefore, this is the number or the factor of 20 that we need to use. Let's try. And now let's try to apply the FOIL method. We have x plus 4 times x plus 5. By using a FOIL method, get the product of the first term to the first term, or x times x, we have x squared. Then the product of the first term to the last term, or x times 5 plus 5x. And the product of the last term to the first term, or positive 4 times x, we have plus 4x. And the product of the both last term, or 4 times 5, we have 20 plus 20. And then simplify, we have x squared, get the sum of the middle part, plus 9x, and copy the last part or the last term, or the constant, the value of the constant, we have 20. That's what you can see. It is equal to our given equation or given trinomial. Therefore, this is now the factor of x squared plus 9x plus 20. Another example, x squared plus 6x minus 27. Factors of 27 are negative 27. As what you can see, we use negative. Therefore, our factor, not all the value of our factors are positive. We use negative numbers. So the factor of negative 27 is negative 1 and 27, negative 27 and 1, negative 3 and 9, and negative 9, 3. And then the sum, negative 1 plus 27, we have positive 26, negative 27 plus 1, negative 26, and the negative 3 plus 9 is positive 6, and negative 9 plus 3 is negative 6. So what you can see, we have a positive value here at the middle part, and it is 6. Therefore, this is the factor of the negative 27 that we need to use. Okay, so x minus 3 times x plus 9. Let's try again to apply the FOIL method. Get the product of the first term. We have x squared, product of the first term and the last term, plus 9x. The negative 3 times x, negative 3x. Then negative 3 times 9 is negative 27. Then simplify, we have x squared. Negative 9 minus 3x is equals to positive 6x minus 27. As what you can see, this is now the final answer, or equal to our given trinomial in a form of x. Okay, may I call on Miss Charlene Katapan? Using a FOIL method, can you please demonstrate to us how to get the product of this given two problems by using a FOIL method? Show it to your classmate using the whiteboard app.
Number 1. X minus 3 times x plus 3. So we need to get the product of it by using FOIL method. First, we need to multiply the first term. X times x equals x squared. The outer term, x times 3, which is equals to 3x. The inner term, negative 3 times x equals to negative 3x. And the last term, negative 3 times positive 3, which is equals to negative 9. So collect like terms. 3x minus 3x equals 0, and the final answer is x squared minus 9. Number 2. X plus 4 times x plus 5. So first, we need to multiply the first term. X times x equals to x squared. The outer term, x times 5 equals 5x. The inner term, 4 times x equals to 4x. And the last term, 4 times 5, which is equals to 20. So collect like terms. 4x plus 5x equals to 9x. And the final answer is x squared plus 9x plus 20.
Okay, very good, Miss Katapan. Thank you so much. We have an
Thank you
activity
so
here.
much.
Let's have an
Very
oral
good, Miss
activity.
Amonte.
Find the
Now
greatest
let's
common
proceed to
factor of
number
each list
2.
of
May
terms
I
and
call on Miss
numbers. For
Kausing?
number 1,
What is the GCF of
may I call
6,
on Miss
8, and
Samonte?
46?
What is the greatest common factor of a cubed b squared b raised to 5th, and a to the 4th b raised to 7?
Okay, sir. So the first thing that we need to do is we need to spread these terms into their factor forms. So for the first term, we have a times a times a multiplied by b times b, which will give us a cubed times b squared. So for the second term, we have A times A multiplied by B times B, which will give us the A squared times B squared. And for the final term, we have A times A times A times A to be multiplied by B times B times B times B times B times B and times B. So which will give us A raised to 4 times B raised to 7. So to determine its greatest common factor, we need to get the common terms among their factors. So for the first term, we have A times A times B times B, which is A squared times B squared. So for the second term, we have A times A times B times B, which is also A squared times B squared. And finally, for the third term, we have A times A times B times B, which is A squared times B squared. So, therefore, the common factors of these three terms is A squared times B squared.
Thank you so much. Very good, Miss Samonte. Now let's proceed to number 2. May I call on Miss Kausing? What is the GCF of 6, 8, and 46?
So 6, 8, and 46. So let me identify first the factor of 6. So the factor of 6 is 2 times 3. Next is 8. So the factor of 8 is 2 times 2 times 2. Last is 46. So the factor of 46 is 2 times 23. So as you can see, the common factors of 6, 8, and 46 is only number 2. Therefore, the greatest common factor or the GCF of the given is 2.
Very good, Miss Kausing. And now let's proceed to activity 1 number 3. May I call on Miss Katapan? For you, what is the GCF of x raised to 12, y raised to 10, x raised to 8, y raised to 5, x raised to 7, y raised to 8, and x cubed, y raised to 4?
Number 3. Find the GCF or the greatest common factor in x raised to 12 times y raised to 10, x raised to 8 times y raised to 5, x raised to 7 times y raised to 8, and x cubed times y raised to 4. And the GCF is x cubed times y raised to 4.
May I call on Mr. Evio? Based on Miss Katapan's answer, the GCF is x cubed and y to the 4th. Do you agree with that, and why?
This common factor is x cubed y to the 4th because x cubed y to the 4th can be seen in every terms. For example, x cubed can be found in x to the 12th power, x to the 8th power, and x to the 7th power. And also, y to the 4th power can be found in y to the 10th power, y to the 5th power, and y to the 8th power. So the greatest common factor all in all is x cubed y to the 4th power. That's it, sir.
Okay, thank you so much, Miss Katapan and Mr. Evio. Very good. And now let's proceed to the last activity, number 4. May I call on Mr. Gifieso? For you, what is the GCF of 144, 256, and 300?
So this will be the prime factors of 144. So same process with 256 and 300. So in 256, this will be the find factors. And for 300, so in getting the GCF, so let's find the common factors. So 2 is the common factors. So there was only 2 common here, so therefore let's write 2 times 2 is equals to 4. So the GCF of 200, the 144, 256, and 300 is equal to 4.
Very good, Mr. Givieso. Thank you so much. How about you, Mr. Freda Marica? What?
Okay, sir. So, first is we need to find the factors of each terms. So, in the first term, we have 144. The factors of 144 is we have 2 times 2 times 2 times 3 times 3. For the second term, we have the 256. The factors of 256 is 2 times 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 2. For the third term, we have 300. The factors of 300, we have 2 times 2 times 3 times 5 and then times 5. So then we're going to find the common factors of the three terms. So as we observe, the common factors of the three terms is 2 times 2. So the greatest common factors of 144, 256, and then 300 is 4.
Okay. Thank you so much for your participation, class. We have not enough time para ipagpatuloy pa ito. So, I've prepared an evaluation or assessment here, and I will post it on our Google Classroom. Answer the following and show your complete solution. Write your answer in a one whole sheet of paper. I will post it in your Google Classroom, in our Google Classroom, and make sure that you will pass it before the deadline. Okay? Okay? And for your assignment, do an advanced study on how to factor trinomials in a form of ax squared plus bx plus c using the FOIL method. Kasi kanina, yung ating pinag-aralan is all about factoring trinomials in a form of x squared plus bx plus c. At ito naman, and for our next meeting, we talk about factoring trinomials again, but in a form of ax squared plus bx plus c using FOIL method. And try to read more books and search it in Google and other websites to learn more. Okay, once again, thank you so much and goodbye. See you again for the next meeting.